Ladies and gentlemen, today we are going to finally look at what radian measure means. So we've talked about that before now. You've always had to have your calculator in degree mode because we have been measuring angles in degrees. We are now going to take a look at what does radian measure do? How is it measured? What does it look like? So 1 radian is the angle formed at the center of a circle by an arc equal to 1 radius of the circle. Okay, so radius of the circle from the middle of our circle to the outside of our circle. So creating that line and the arc of our circle. And our radius is this measure in here. So if our arc and our radius are equal, then we have a radian. If we have 2 radii, that means that our arc is twice as big as our radius. So again, we have our radius, and that length once and then again creates an angle in which we would have 2 radii. Now, if we're talking about all the way around the circle, what do we know about that measure? Well, then we are going to take a look at, and let's take a look at our measures. So for our first one, theta is equal to the arc length, which is represented by A, divided by the radius as R. Well, if A over R are the same, so our arc is the same length as our radius, then you're going to have 1 radii over 1 radii is equal to 1 radian. For our second one, now we have, and we're just using theta 2 for our second example, arc over the radius. Now we have 2 radii over 1 radii, or 1 radius, is equal to 2 radians. Well, when we take a look at our third one, our arc over our radius. Our arc in this case is 1 rotation around, which we know how to measure as circumference. So 2 pi r over radius means that 1 full rotation is 2 pi. So 2 pi radians is 1 full rotation, which by extension means that if we are changing radians to degrees, we know that 2 pi is equal to 360 degrees. So pi has to be equal to 180 degrees. Well, if we wanted to figure out how to transfer from one to the other, we can use this. And we can take a look at that. If we want to know what 1 radian is, then we're going to take our 180 and divide by pi. If we want to know what 1 degree is equal to, then we would have pi divided by 180 in radians. And we're going to take a look at exactly how we do this in some examples too. So example number 1, converting to degree measure. Well, again, 1 radian is equal to 180 degrees divided by pi. If we want to take a look at how to calculate pi over 6, we're going to multiply both sides of this by pi over 6. 1 radian is 180 over pi from what we talked about over here. And we're going to take 180 over pi and we're going to multiply that by pi over 6. We're just multiplying both sides by pi over 6. And now we're going to simplify this. Our pi's cancel out. We can also simplify diagonally. 6 divided by 6 is 1. 180 divided by 6 is 30. So pi over 6 is equal to 30 degrees. Same idea over here. If we know that 1 radian is equal to 180 over pi, we're going to measure 5 pi over 4 by taking 180 over pi and multiplying by 5 pi over 4. Again, simplifying diagonally, pi's cancel out. 4 and 180 are going to simplify. And now we're going to be left with our angle in degrees. 45 times 5 gives us an angle of 225. We're going to do the same thing. If we have negative radians, it simply means that it is clockwise rather than counterclockwise from the x-axis. And 180 over pi times negative 7 pi over 2. Pi's cancel. We're going to be left with 90 times negative 7, which is equal to negative 630 degrees. Okay, so we can translate angle measures just like we can translate imperial to metric and vice versa. Example number 2, we're going to go the other way now. We know that 1 degree is equal to pi over 180. Again, if we ever forget that, we just go back to 180 degrees is equal to pi, dividing 180 on both sides. We know that 1 degree is equal to pi over 80. Well, now we want to know what 45 degrees is. We're going to multiply both sides by 45. And remember, 45 is just like 45 over 1. We can simplify our diagonals. 45 divided by 5 is 1. 180 divided by 45 is 4. So 45 degrees is equal to pi times 1, which is just pi, and 4 times 1 on the bottom. So a 45 degree angle is a pi over 4 radian angle. Same thing for 150 degrees equals pi over 180 times 150. Simplifying diagonally, we notice that both of these will divide by 30, leaving us with 6 and 5. So 150-degree angle in radians is 5 pi over 6. Pi over 180 times 20, again, simplifying, divided by 20 leaves us with 1 over here, 9 on the bottom. So a 20-degree angle is equal to pi over 9 radians. And notice that we don't necessarily have to put RAD after all of these calculations. As soon as we see pi as part of our angle measurement, we know we have radians. Example number 3, we want to find the number of radians to the nearest hundredth. So we're still going to do the same thing, but we're going to use our calculators to figure out our decimal. So 90 degrees equals pi over 180 times 90. And we're going to get pi over 2. And in our calculators, we are simply going to put in pi from our pi button divided by 2. And when we do that, we're going to round to 2 decimal places. So we get 1.57 radians. Here, because we don't have the pi as part of our measure, we do want to put RAD, or radians. 225 pi over 180 times 225. And we can simplify. We don't have to in this case. It's a harder thing to simplify than it was in the first one. So we can just put this all in our calculators. So we're going to do pi, using our pi button, divided by 180 and multiplied by 225. And when we round this, we get 3.93 radians. Okay? And again, we want to get more used to, we know that 180 degrees is pi. If we have just over 180 degrees, we should just have over 3.14 radians as well in decimals. Example number 4, we want to convert to degree measure to the nearest degree. So same idea as we did the last question. We are going to just use our decimals in this case. So we are going to have 4.2 times our 180 over pi. And again, we can just put this straight into our calculators. 180 divided by our pi button times 4.2. We're going to round to the nearest degree, which is 241 degrees. Same thing here. 180 over pi times 0.785. In our calculator, rounding to the nearest degree, we get 45 degrees. Now, drawing in standard position, we want to keep in mind we are going from our initial arm of the x-axis. Now we want to think about, we know that a full rotation all the way over to here is pi. Well, if we have pi over 2, we know that we're going to have half that distance, which means that our terminal arm is on the y-axis, which is a 90-degree angle. So we know that pi over 2 equals 90, and we can draw our terminal arm that way. Now, negative 5 pi over 6. There are some base angles that we want to know in radians. So we are going to have to know our 30, 60, 90, 45s in terms of radians. Well, we know that a pi over 6 angle, if we think about pi over 6, which is the denominator here, pi over 6 is equal to a 30-degree angle. Okay, and we know that by taking pi over 6 times 180, simplifying, we know, times 180 over pi, our pi's cancel and we're left with 30 degrees. So what we're doing from our initial angle, we can count 6 so-called 30-degree angles. So we're going to have 1, 2, 3, 4, and our fifth one creates our angle of negative 5 pi over 6. So we can think about this as negative pi over 6. This is negative 2 times pi over 6, or negative pi over 3. Negative 3 pi over 6, or negative pi over 2. Negative 4 pi over 6, and negative 5 pi over 6. Third one, we have 5 pi over 4. Again, we can think about what pi over 4 is. And if we think about pi over 4, we can take, because pi over 4 is going to be one that you want to know, so we're going to take pi over 4 times 180 over pi, and simplifying, we see that we have a 45-degree angle. So again, we can measure from our initial arm 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and our angle is 5 pi over 4. So we have 5 pi over 4. So again, there are certain measures of radians that you need to know that are equal. So pi obviously is equal to 180, dividing that by 2, so pi over 2 is 90. Pi over 3, or 180 divided by 3, is a 60-degree angle. 180 divided by 4 is a 45-degree angle, and 180 divided by 6 is a 30-degree angle. We need to know these off by heart. It should almost be automatic. So, two angles coterminal to pi over 6. So we know that our pi over 6 angle is equal to 30 degrees. So we know that we have a pi over 6 angle in here. When we talked about coterminal, we know that it's one full rotation. Well, we can find coterminal angles then by adding a full rotation. A full rotation in this case, in radians, is equal to 2 pi. So we're going to take our pi over 6 plus 2 pi, which when we get our common denominator, pi over 6 plus 12 pi over 6, means that 13 pi over 6 is coterminal. We could also take away a full rotation. So subtracting 2 pi, which means we're going to have pi over 6 minus 12 pi over 6. Another coterminal angle is going to be negative 11 pi over 6. Okay, so we know now what radians are, and you're going to have some practice in your worksheet for today. So take care, and as always, let me know if you have any questions.